last but not least, we're going to go back to Karim.
All
Is
right.
your things working better now?
Yes, let me share. Okay. Can you see my screen?
I can.
Okay. All right. Let me go back to the beginning. So I just use the same, the same presentation style that you use, and I picked the question 5.3, which is about quality control. So an engineer picked a random sample of 212 chips and found out there are 27 that are defective. So the first question about the population under consideration, which is the complete sample, and it's like 212 chips. And the second question is about what's the parameter is being estimated, and that's the chips that had defects, and they are 27. And the third question is about what's the point estimate for the parameter, and we basically divide the defective chips by the complete sample, and that's almost like 12.7%. And what's the name of the statistic can we use to measure the uncertainty of the point estimate? And that's the standard error. And how to compute this standard error? We basically use the square p by 1 minus p divided by n, and that gives us around 0.023. And the next question is about so the historical the historical rate of defects is 10%, and should the engineer be surprised of the defects rate? And the answer is no, because the difference between the p-hat and the historical defects rate is higher than the standard error, and it's like 0.027, which is the standard error is 0.023. And the last question is they wanted us to use p instead of p-hat. So basically we apply the same formula, and it gives us around 0.021, and that's like very close to when we use the p-hat. So when we use the p is just very close. And that's it for me.
Thanks very much. All right.